Gee, I'm a tree. Okay, today we're talking about circle segments. This is lesson number 4. It's called Two Intersecting Tangents and Common Tangent. I'm going to be talking about two different situations, but the first thing we're going to talk about, just like before with the secants and the chords, and the secant intersecting with the chord, with the tangent, is that we're looking for the line segment when we're talking about two intersecting tangents. So let's get going. Now, when two tangents to the same circle intersect, what happens is we end up getting two parts or two segments, AB and AD. When this happens, the two tangents are equal to each other. Okay? So basically, AB is equal to AD. Simple concept. Now, instead of just jumping into some basic ones, we're going to sort of jump into examples that you could possibly see on the Regents exam. Let's get now. They give you a triangle with a circle in it. EF is 24. DF is 32. And AD equals 18. I want to find the length of EA. Now, since I have no x's involved, I can easily just put an x there. The key fact is what we had before, is when the tangents are intersecting, they are equal. So if we take a look here, this is really made up of one tangent, but there's two different segments on the tangent ED. I have AD, which is when the circle, A is where the circle touches, so AD and AE. However, AD and ADC, if we just sort of cover this up, you notice that it looks just like the previous, just like your notes, where it says that these two parts are equal to each other. So 18 here, this is going to be 18. Now if I know the whole thing is 32, and this is 18, then therefore we can do our little subtraction, 32 minus 18, and I get 14. That means this segment's 14. Now if this is 14, then this is 14. If this is 14, I know the whole thing is 24, then therefore I know that this here is 10. If this is 10, then therefore x is equal to 10. And therefore I know that the length of EA is 10. Now, I sort of love these problems. I think they're sort of super awesome, but let's go over one more. Oh no, we have that colon came back. Now, if EB is equal to, if EB to DF, BF equals 1 to 2. I'm talking about EB and BF. Remember, when you have a ratio, you put the x's. EB is the first one, so EB is going to be x, and BF is going to be 2x. Now, let's finish marking up the diagram before we jump in. So DF is 20. This whole thing here is 20. And AD is 14. I want to find the length of ED. So what we can do is we look at the diagram. I still have tangents. So this is 14, then DC is going to be 14. Okay? Now if this is 14, then therefore this here, since the whole thing is 20 and this is 14, 20 minus 14 gives me 6 left over for this part. Now, 2x is equal to 6, and that means x is equal to 3. Okay? Now, I'm looking for the length of ED. That's this whole segment over here. So, if this is going to be 6, I know x is 3. That means EA is 3. And to find ED, we add 3 and 14. So 3 plus 14 gives me 17. So therefore the length of ED equals 17. Cool. Now, let's take a look at the last part of this, called the common tangent. Okay? So, the common tangents. The common tangent is the number of lines that can touch two circles at one point each. Now, this is when we have two separate circles, and we're looking for when they are actually going to be have the same line that's going to be touching. Now, typically on the Regents, they may possibly ask you a question like this. And also in this class, we're going to ask a question. So let's take a look at the examples. Now, you're going to need a ruler for this. You want to find the number of common tangents. And this is 5 different situations. And these are the only 5 situations you could possibly have. Now, in circles O and A on this left problem, I can draw a tangent right here. Okay, sorry, it's a little intersecting, but there's one tangent that I can draw. There's another one over here. So there's 2. Now, if we take a look in the middle, what happens is I can draw one this way, going O down to A. Okay, and then I can also draw one more that goes over here. So this leaves me with 4 common tangents. You'll never really be asked to draw these, but with these, it's sort of a good idea just to have an idea. Now, the problem is when they're touching, now these 2 circles are touching each other. Now, we still have that top tangent, we have the top tangent and the bottom one. They're still the same. But in the middle, I can't create 2 different tangents like we could over here. What we can only create is this one that goes right through that point that they're both touching. So that gives me 3 common tangents. Okay. Now, if I take a look at this one right over here, I have 2 circles that are intersecting. I know you're thinking, oh gosh, it's a Venn diagram. We're not talking about Venn diagrams here. But if I have 2 circles that are intersecting, I can't draw one in the middle anymore because it's going to go through the circle, because there's no way that I can just touch the circle at one point that go through the middle. So I can still use that top one and the bottom one, leaving me with how many tangents? 2 common tangents. Okay, let's take a look at the next one. This one's a circle, A, the big one, and then I have the little circle, O, and it's touching at one point right here. Now, I don't have a top and bottom anymore because, once again, if I go to the top of circle O, I'm going to end up inside the circle for A, and that's a big no-no. But I can draw the one tangent, a line, that's touching the circle at the point of intersection. So this is one tangent. And then finally, we look over here. Now I have circle O is completely inside of circle A. There's no, circle O is sort of stuck in the middle. In this case, there are 0 tangents. Okay, hope you learned something. If you have any questions, feel free to leave a comment or email me. Anyway, talk to you later. Bye.